Hello everyone and welcome back to our third video of the channel, and then this will be the first video of our physics series. I'm quite excited. Physics is a really challenging subject, and it's usually quite intimidating for most of the people because it involves a lot of maths, a lot of calculation, and it can be a bit confusing sometimes. But I'm telling you, physics is actually not that scary. The math of it is actually not as hard as the math that you will get in your normal math lessons. But it's the concept of it that usually caught people out. So today we're going to introduce a very simple concept of mass, weight, and a slight introduction to turning effect. And just tell me how you feel about this video. Am I expressing myself clear enough, or are there any more improvements I can do? What is mass? Mass is basically how heavy an object is. So this might help explain it. When we measure mass, we use the unit kilograms. And we need to know 1 kilogram is equivalent to 1,000 grams. And we need to be familiar with converting from kilograms to grams because it's really common for units to change in physics. So let's take an example like an apple. An apple, the mass is usually 100 grams. And that would equal to 0.1 kilograms. And an average female would be 55 kilograms, while an average male would be around 75 kilograms. So this is pretty basic. It's a pretty simple concept. It's basically how heavy something is. This is when it gets slightly confusing. When we talk about mass, it's about how heavy something is. But how about weight? When people usually ask, how much do you weigh? You answer them with kilograms. For example, I weighed 60 kilograms. But you rarely understand what the word weight actually means. So in order to understand weight, we have to start with something called acceleration due to gravity. And what does that mean? Well, in physics, we represent this with a small letter g. And the acceleration due to gravity on Earth is 9.81 meters per second squared. And usually we round it up to just 10 meters per second squared for a more convenient calculation. And that's the situation on Earth. So what does this mean? What does this acceleration mean? It's basically how strong the gravitational field on Earth is. So the stronger the gravitational field, the heavier you will weigh. So weight is actually determined by gravity, whereas mass is independent from gravity. That means your mass will always stay constant no matter where you are, whereas your weight will change depending on which planet or which environment you are in. So for example, if we take the moon, the gravitational acceleration is a lot less. It's around 1.6. And if we take Jupiter, the gravitational acceleration is 24.8, which is almost 2.5 times than the gravitational acceleration on Earth. So now we understand the acceleration of gravity, and it's time for us to calculate weight. How do we calculate weight? This takes us to our first equation, W equals mg. So what does this mean? I'll break down the equation to make it easier. W in this case means the weight, and we give it a special unit called Newton, which is written as an abbreviation of N. And we have m, and that's our mass. Our unit will be kilograms. And we have g, that's our gravitational acceleration. The unit would be meters per second squared since it's an acceleration. And we usually just round it up as 10. So in order to calculate something's weight, we have to take the mass and multiply it by 10 if we were on Earth to get out the weight of the object. Then how do we apply this formula on our normal life? Let's take an example. For example, like a cat. And a cat usually has a mass of around 5 kilograms. So let's take our equation. W equals mg. If we want to find out the weight of the cat, we have the mass, which is 5 kilograms. And we have the acceleration due to gravity, which is 10 meters per second squared. And on Earth, we will take 5 times 10 which will equal to 50 newtons. But if this cat were to be on, for example, the moon, we will take 5 times 1.6 equals 8 newtons, because the acceleration on moon is far less than Earth, which is 1.6. Or if the cat is on Jupiter, we will take 5 times 24.8, which will equal 124 newtons. So now you can actually see the mass of the cat remains unchanged no matter where it is. So it's 5 kilograms on Earth, Moon, and Jupiter. However, due to different planet accelerations, the cat's weight will actually differ from 58 or to 124. So this takes us to turning effect, and turning effect is actually a pretty interesting effect that happens all around us, and yet people don't really pay attention to it. So let's start simple. Let's take something like a door or a wrench. Now let me ask you a simple question. If I ask you to push open the door, would you push it at the knob or away from the knob? And same for the wrench. If you were to screw something with the wrench, would you hold it here or there? And why would you do that? In order to explain turning effect, we need a very essential equation. So let's take a look at this. Work done equals Fd. What does this equation mean? Well, let's start with work done. What is work done? So work done, in other words, we can call it energy. So it's basically the energy you put in to do something, the work you have done, and it is measured in joules, and we'll abbreviate it with a J. And F will be the force, and that's measured in Newton, same as weight in the previous equation. And the next one will be D, and D will be the perpendicular distance from the pivot, and we will measure this in meters. Well, what does this equation do? How can we actually apply this equation in order to work out how a turning effect of something works? In order to achieve that, we have to start with pivot. So what is a pivot? Well, let's take a look at our doors again and the wrench. So can you find out, just pause the video for now, can you tell me where is the pivot? I hope you had a good go to find out where the pivot of these two objects are. Let me just tell you the answer now. Where is the pivot? Well, it's here and here. Can you spot them? And what makes them the pivot? What makes something a pivot? So just imagine, a pivot is basically the center point when something turns. If you look at the door, when you push or either pull the door, the whole door moves or turns. Well, the pivot is the center of the turning effect. So when we open the door, the pivot actually doesn't move. It's the center. Same for the wrench. When we screw, the screw in the center, the nut in the center, is actually not moving, whereas the whole wrench is turning. That makes something the pivot. Now we know where the pivot is. Now let's come back to W equals Fd. And how can we use this formula? So let's take an example again, the wrench. So the energy required to screw a screw, for example, would be 30 joules or 30 J. Well, we have two scenarios. One is when we place our hand 0.3 meters away from the pivot. Another one is when we place our hand 0.1 meters away from the pivot. And which one would you assume that would cause us more force? Well, we can find this out by rearranging the formula. So if we want to find out the force would equal to work done over the distance, or work done divided by the distance. In this case, it will be 30 divided by 0.3, which will equal to 100 newtons. Whereas in the other case, it will still be force equals work done over distance, but we'll have a slightly different answer with 30 divided by 0.1 equals 300 newtons. So you can see the two forces required will be different depending on where you place your hand, because we have a smaller distance here at 0.1, which makes us require more force, whereas in this case where we have a bigger distance, we need less force. So this will eventually lead us to a conclusion, and the conclusion is, if we are further away from the pivot, the distance will be greater, therefore we require less force to turn it. Whereas if we're closer to the pivot, we will have a smaller distance, then we need more force to turn. And this can be proven by the equation and the screw example. If we place our hand 0.3 meters away from the pivot, we will only need 100 newtons of force. Whereas if we place our hand 0.1 meters away from the pivot, we will need 3 times as much the force, which is 300 newtons. So this is why you feel like it's easier to turn something when you hold it further away from the pivot, and it's harder to turn when you hold it closer to the pivot. This brings us to an end of the episode, and so just to sum things up, of the two formulas that we've seen today, one is W equals mg. It's basically how do we calculate weight using mass and gravitational acceleration. And another one is work done, how this can actually explain turning effect by multiplying the force by the distance. So next week, we'll be discussing about principle of moments. How can these two formulas, somehow seemed unrelated, come together to explain the principle of moments? And I'll end this as a little cliffhanger here. So next week we can carry on to explain how principle of moment work with these two equations. And of course, always like the video and then subscribe to our channel, and share this video to the friends who hate science. And make sure to check out our Instagram page as well. Follow us on Instagram, and just comment down below any more improvements you want to see, and that will be very much appreciated. Thank you, and see you next week.